We're gonna skate to one song only.
Okay, so for our video, we decided to go out to the Manchester baseball field and do some baseball tryouts to see how physics relates in our daily life. Basically, how it interacts the ball with the bat. The group, it's Kai, Caleb, Kristin, Jackson, JT, Eugene, and Juan.
The incoming tennis ball has momentum, which is equal to its mass multiplied by its velocity. And also, when the ball impacts the bat, we hear the collision, among other things. Therefore, we know that there must be energy lost in the collision. So, from this, we can determine that the collision is an inelastic collision.
Okay, so for our second scenario, we had a ball thrown, and we draw the force diagram for the ball, the forces interacting with the ball, and we pretty much only have the gravity force and the air resistance. And you might ask, why is it still moving towards the right since there's no force acting on it? It's because of the momentum it still has from the arm force that was before thrown.
Okay, so here we're going to analyze the batter hitting the ball and sending it over to the catcher. So in this situation, it is an inelastic collision between the bat and the ball, so momentum would be conserved. This means that the initial momentum will equal the final momentum. So the mass times the velocity of the bat plus the mass times the velocity of the ball is going to equal the mass times the velocity of the bat after the collision plus the mass times the velocity of the ball after the collision.
Now we'll look at the torque at the moment of impact. And so imagine that this diagram is just in a plane that includes the direction of the ball's motion after the collision. So if we assume that right at the moment of impact that the bat is stable, then from what we've learned about torque, we know that all these forces must cancel out, or the sum of them must be equal to 0. And so this dot represents the center of mass, and here's the force of the ball on the bat. So imagine that the ball is then going to travel this way, and then it's a two-handed grip, so one hand is exerting a force in this direction and the other hand is exerting a force in that direction. And if the bat is stable, you can balance the torques and the forces, and they will equal 0.
Alright, and as the ball comes down, it hits Sunit's head and bounces off into his glove. So at first there's an inelastic collision between Sunit's head and the baseball. So due to conservation of momentum, most of the momentum carries through Sunit's head into the earth, and then some of the momentum bounces the ball off of his head and into his glove, where there is a perfectly inelastic collision because the ball sticks to the glove.
I'm not the man they think I am at home. Oh no, no, no. I'm a rocket man. Rocket man, burning out his fuse out here at home. And I think it's gonna be a long, long time.
For the next part of our video, we focused on the projectile motion of the bat flying through the air, and the acceleration is always pointing down, and velocity is pointing horizontal to the direction the bat is going. And you can find final velocity by adding the initial velocity with the integral of the acceleration, and the final position by adding the initial position plus the integral of velocity.
Mars ain't the kind of place to raise your kids. In fact, it's cold as hell.